Math 6, Module 6, Lesson 14, summarizing a distribution using a box plot. Excuse me. Students construct a box plot from a given set of data. Now, you need to know this. A box plot is a graph that is used to summarize a data distribution. Now, you need to think about this. It doesn't just describe or summarize data, but the distribution of it. Okay. What does the box plot tell us about the data distribution? How the box plot indicates the variability of the data distribution? And these questions are explored in this lesson. Example 1, time to get to school. Considering the statistical question, what is the typical amount of time it takes for a person in your class to get to school? The amount of time it takes to get to school in the morning varies from for the students in your class. Take a minute to answer the following questions. Your class will use this information to create a dot plot. Now, we're not necessarily going to do that. We're just going to work on this. Okay. But you can imagine some take 3 minutes, and then some that live in Seoul, it takes an hour. Okay, so there's going to be a bunch of different answers here. What were some of the things you had to think about when you made your estimate? Well, sometimes you have to wait on the bus. Some of you have traffic to deal with. Some have to wait on the train. And it only runs at certain times, right? Some of you may have to walk with your sister, a younger sibling. And in case the bus is late, sometimes it's stuck at the station waiting on people. There's just a lot of different ways that could affect your time getting to school. But that's the reason why it's considered a statistical question. You're not just going to get one answer. Okay. For me, it takes about a 3-minute walk. But if I have to wait for to cross the road for a while, then it may end up being a 4 or 5 minute walk. Now, exercise 1 through 4. Here's a dot plot of the estimates of the time it took students in Mr. S's class to get to school one morning. Now, this is put a line on the dot plot that you think separates the times into two groups. Okay, one representing the larger time and the other representing the shorter time. So that would be right here. That would be this line right here. That would be the one that represents maybe the upper half and the lower half. Okay. Now it says put another line separating the times that live close to the school, which would be these that have the shorter time frame, right? So this would be the ones that live closer to the school. It shouldn't be taking them as long to get to school as those that live far away, right? And then the ones that do live farther away, you'll have to separate those. So we do that. So at 10 and at 30. Now, number 3 says your dot plot should now be divided into 4 sections. 1, 2, 3, 4. Now it says record the number of data values in each of the 4 sections. So we would count how many they are in each section. Depending on the division, is 7 or 8 in the lower one. Okay? And then 9 in the next, and 5 in the upper section. Now, here we go. So, if we're looking at this, remember, if we think this dark line here between the 2 and the 3 is the middle, then there should be about 50% of the students that are within this time frame. Okay, just need to remember. Now let's look at page 3. Time to get to school. Here we go. Here's the times. They're already ordered in least to, or smallest to largest. Okay, and what is the value of the median time? Well, how would we do that? Well, we're going to count and see what's in the middle. Right? How many are they? You're to count all those up. There are 27 different times, so that means the 14th value is the median, and that happens to be 15. Now, which 15? Because there's 4 up here. Well, we got to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It is this 15 right here. So what is the value of the lower quartile? So now we got to find the lower quartile. Well, if this is the 15th, I'm sorry, if that's the 14th value here, then that means there's 13 values in the lower and 13 in the upper. Okay? So if there's 13 in the lower and the upper, 13 divided by 2 is 6.5. We round it up to 7, not up to 8, up to 7. Then the 7th value is the median of the lower quartile. So 1, 2, 3, 4, 5, 6, 7. So 10. And let's see about the upper. 1, 2, 3, 4, 5, 6, 7. Uh-oh. Something's off here. Hold on. Did I miscount? 1, 2. I only got 26 values here. But I'm missing one over here. I was missing this 5 hidden right here. Sorry about that. So let's rearrange this just for a second. That would mean this 15 is the median, which would give us 1, 2, 3, 4, 5, 6. This would be the median of this one, and then 1, 2, 3, 4, 5, 6, 7. Yeah. So there's our Q1. And then this is Q3, where the 15 is the median. So what is the value of the lower quartile? Well, the 7th value is the one that's in order there. Did I miscount again? Well, this has us as 8. 1, 2. I did. How about that? Miscounted again. This 8 is the lower. Okay. I just can't count with this, and it don't want to stay over here. If you count over, that'll be the 7th value. Now, it says these lines on the dot plot below indicate the location of the median, the lower quartile, and the upper quartile. These lines divide the data set into 4 parts. What fraction of data values are in each part? This is what I've been telling you to remember. This should be 50%. This should be 25%. And this should be 25%. Now, if we were to break it up into 4 parts, this would be 25%, and this could be 25%. So each part would be 25%. So they're about 3/4 of the data values in each part. That is wrong. That should be 1/4. Okay? Now, 4. Now we're making a box plot, or this is what I used to call the bots, or what we call whenever I was in school, a bots and whisker plot. Okay, so how do you do that? If I were you, I would write these things down. To make a box plot, you find the median of all the data. Find Q1. Find Q3. Then you're going to draw a line. Okay, draw a number line, and then draw a box that goes from Q1 to Q3. Okay, so here's our here's Q1. This is the median right here. This is Q3. And then this value right here is called the minimum. And then this is the maximum. Okay, and it'll look something like that. Now, using the number line to make a box plot for the data below. All right, we've done that now. If you were to add this up, 1, 2, 3, 4, 5, 6, 7, 8, 9, that means the fifth number will be the median. And right there it is, 35. There's the median. Now we take the median here, this would be 41, and this would be 23. And here they are, 23, 41. The maximum value is here at 44. The minimum value here at 20. So this is called a 5-number summary. We have the minimum, the Q1, the median, Q3, and the maximum. And each one of those are represented here in this box plot. Okay. So why is it important to have a standard way to make a box plot? Well, because it guarantees that everyone will have the same plot when given the same set of data. Okay, there's a standard. What does a box plot tell you about the story in the data? Well, a box plot's divided into 4 parts. Each contains about 1/4 or 25% of the data values. The box part, though, here represents 50%. All of this should be about 50%. I said should be. It's not 100% every time that it's going to be 50%. The box plot does not show us specific data. That's the problem here. We don't have specific data points on the box plot. So what proportion or percent of the data set are in each of the sections? Well, we've already talked about that, 25%. All right, lesson summary. You learned how to make a box plot by doing the following. You need to know how to make a box plot. Memorize those.